Hello, my name is Lemordant from Columbia University, and I will talk today about the modification of the land-atmosphere interactions by the CO2 and their implications for summer dryness and heat wave amplitude. What we've done is a simulation of the 2003 heat wave in Europe using a regional climate model framework, and to study three different feedback that can occur at different time of the year, during the spring and during the summer during a heat wave. We used this model to have a base case scenario, and then we increased the CO2 level only in the surface model, so that the vegetation sees more CO2, but the atmosphere stays at the base case CO2 level, and we don't have the radiation feedbacks. What we observed is an increase of the soil moisture during the spring, which correspond to this feedback, which is an increase of CO2 level drives an increase of water use efficiency, and that increased the soil moisture availability. In turn, we observe also a decrease of latent heat flux, which is the direct consequence of this feedback. But we can see that later in the year, this feedback decrease, which corresponds to these feedbacks, which is the fertilization effect of the CO2 of the vegetation. More CO2 means more biomass, or latent leaf area index, for example, which tends to deplete the soil moisture and increase the latent heat flux. This is what we observe here. And these two combined effects drive also the increase of the sensible heat flux and the increase of the temperature. Now, during the summer, we observed the opposite effect, where the availability of the soil moisture is there to sustain higher latent heat flux, which drives also a different partition of energy and less sensible heat flux, and we see a decrease of the temperature compared to the spring. So the blue line is the fair run, which is the CO2 is increased only in the surface model, and the red line is the fair dry run, which is a replica of the fair run, but where the soil moisture is fixed at the level of the control run. So we cancel the effect of the soil moisture, which is this feedback. So the blue shaded area is all these feedback together, whereas the red shaded area corresponds only to this feedback. And we can see that if we quantify each one of these feedback, and especially this one against this one, they are almost of the same order of magnitude. And geographically, the soil moisture increase all over all over France during spring, and decrease afterwards. Similarly, the latent heat flux is really stimulated all over the domain, and the sensible heat flux as well decreased in the opposite direction. And for the temperature, the distribution is much less significant quantitatively, and much more distributed all over the domain. And this is mainly due to the setup of the experiment of the regional climate modeling framework, where we have to set up the temperature fixed at the boundaries of the domain. So we can't see as much effect as for the sensible heat flux as we could expect. Thank you for listening, and see you at the ETU.